So today I want to talk with you about proxies. We believe that proxies are really great thing and that they are really undervalued currently in the ecosystem. So that's why I want to bring you some quick introduction into proxies and how they could be used, how we use them, so you can actually apply it to your day-to-day operations as well. So the agenda for today is to firstly discuss some essentials of proxies, to basically some theory behind them. Then we'll check the best practices for how to use proxies. By best practices here, I mean the different setups you can construct and arrange in order to utilize proxies in a really efficient and flexible way. And finally, I will go quickly through a small demo demonstrating how you can use proxies in Novasama products. So the essentials of proxies. I guess the first question is, what are really the proxies? And in simple terms, proxy is really a simple concept. It's about granting permissions to some other account for this account to execute something on your behalf. So let's stop a little bit here for everyone to be on the same page regarding the legend I will use throughout the presentation. So there are two main entities participating in any proxy communication. It is a proxy account, which is account that receives permissions, and there is a proxied account, which is the account that grants the permissions. So the proxy account will always be denoted at least partially by a filled green square, and a proxied account will be a white rectangle with a green border, but I think you can't see the green border, so it's just a white rectangle. So here's an example of a diagram you will notice a lot during this presentation. So it's a diagram that describes a simple proxy-proxied relation. So proxied grants permissions for proxy, and proxy can execute something on behalf of the proxied. Does anybody have any questions up to this point? Okay, good. So let's move on and start with regular proxies. Regular proxies, it's probably what you would think of if I will tell you to imagine granting rights to someone. It's like I have access to my account and I want to give certain permissions to other account to execute on my behalf. So let's look at the whole flow about how we'll actually set up such a connection and execute proxy transactions. So initially there is a proxied wallet, which is our wallet, which might be my cold wallet or some other wallet I want to grant certain permissions from. It's named proxied here, and will always be throughout the presentation be labeled that way. So proxied will always be labeled like proxied. Proxied issues a specific extrinsic, which is proxy add proxy, to indicate that it wants to add proxy, which is a green square here, to grant proxy a certain set of permissions. Once the extrinsic is successfully executed, there will be a connection established between proxied and proxy, which is indicated by green line here. And after that, proxy can execute certain transactions on behalf of proxied by executing proxy and wrapping real operations into proxy basically. So you might ask, how can I make sure I will limit this connection only to a certain set of operations? Luckily for us, there are different proxy permission types available. So here I will focus on the ones available on Polkadot, but it's important to note that this is highly configurable and can be changed by any chain in any way it wants. So the permission that's usually present everywhere is any. So it's basically you give the other account rights to do anything on your behalf. It might be dangerous, so you should take it. You should consider using it with care. Then there's non-transfer type, which stands for itself, I guess. It's just allowing execute anything that doesn't do transfer, involves transfer. Then there's also staking, governance, and a few more, which I guess are pretty self-explanatory. but if you have any questions, you can ask a little bit later. So now let's talk a little bit about how you can use regular proxies. The main, I would say, use case for regular proxies is simplify access to some other account. Will it be your cold wallet, which you want to allow a certain operation for example, staking? It's actually the most used use case. If proxies are used anywhere, it's staking proxy to simplify access to a cold wallet. Also, it's like 90% of usage. So we will discover how you organize it and how you operate it a little bit later when we go to best practices. And the other one is when you want to simplify access to some keyless account, for example, to multisig, which can be, again, just simply signed. So you like have a multisig, but you want to do quickly some certain operations which are, let's say, not destructive enough to involve every signatory of your multisig to review it. So, however, there are a few limitations of regular proxies, which I guess are a little bit pretty minor, but still it's worth mentioning. So, firstly, it might not be actually, it's like not a limitation, but just note that proxy is always controllable by other means. It doesn't usually matter if you're not doing some setup that requires assurance that the proxy is actually only controllable by proxy. We will view some examples later on. And the other one, which is common for all proxies, is that you should place a deposit when creating a proxy until the proxy is deleted. That's in order to basically like compensate chain for usage of some storage and stuff that's required for proxy to function. Do you have any questions about regular proxies, maybe?
Yeah, you can ask.
Thanks. Does a non-transfer proxy, can it create new proxies of a lower type?
Well, that's an interesting question. I know that any proxy can do that, but I'm not sure about any transfer, to be honest. I think it should be able to.
Because I don't remember either. I thought you might remember. Okay, but okay.
That's the one point I was thinking about, like before the presentation. Like somebody will certainly ask about it, but I didn't have time to check it.
Okay. Okay, go ahead. Or another question.
So you mentioned there's a proxy type called any.
Yeah.
Right. I'm just struggling to find what's the use case for that. Like, why would I want to use an any proxy? Why not just use the account itself?
Yeah, you're right. In regular proxies, there are really not a lot of use cases you can use it for, but it might become useful with other types of proxy, and you will see how in a little bit later. Thank you. So let's go to the pure proxies. So remember, one limitation of regular proxies is that somebody controls it in some other. Sorry. Somebody controls it in some other way. So in order to mitigate that, we can utilize a concept of pure proxy. It is a way to basically set up a completely new proxied account, which will initially only be able to be accessible from the account you are setting up it from. So to make it a little bit more visual, let's again assume there's a proxy. Note that in this case, we start with proxy. So somebody wants to set up a new proxy for themselves. So we start proxy with a green rectangle, and we execute proxy create pure. This will initiate the creation of a pure proxy, and as a result, we will have a connection from freshly created account, which is named pure proxy here, to our proxy, which is our account here. So it again requires placing a deposit. It requires paying the fee and all of that stuff. And note that we can, basically you specify the permission type we'll use. But I highly encourage everyone doing so to always start with any type, because otherwise you won't be able to properly manage the pure proxy. As mentioned before, A non-transfer might be able to do it too, but I'm not sure. So in conservative way, you should always start with any proxy. So once pure proxy is created, you can start using it from your proxy, which you use to initialize the creation, basically, by doing basically the same operation, proxy.proxy. From now on, it's the same as with regular proxies. So only the creation process differs. So that's quite, I would say, might be a confusing concept, especially from the beginning. Like, why would you need that? So there are a few interesting use cases actually with pure proxies. One is that you can create a brand new account that you will initially be in control of, but that you can later switch to other. You can give other people permissions to later on. I can give you one example when we actually have to use it. So there is a parachain, HydroDX, I hope you know it well. So at some point, it is a parachain focused on swapping, DEX, and finances. So at some point, they have integrated the referral program. And the one limitation of the referral, so the flow with the referral program was that you have to create a code, like a referral code, link it to some account, which will receive rewards from your referrals. And the limitation was that you aren't able to reassign the link. So once you link certain code to an account, you can't change it. So we were in a really huge rush because we really wanted to claim Nova referral code before anyone else. We know some people might want to troll us and claim it quickly before us, so we really were in rush. So we didn't have time to decide what and how will be control of this referral account to claim rewards and stuff. So we just set up a pure proxy, quickly used it as an account to link referral code to, and then we just in a calm way decided how to manage the permissions correctly. So it's really flexible because you don't need to change the account, you just jungling these permissions here and there. And the other interesting use case is flexible multisigs, which is basically a setup to overcome a limitation of Polkadot multisigs, them being unchangeable in terms of signatures, like you can't change the threshold and the signatures. So there is a setup that can overcome this. I will show both of them a little bit later. So again, there are a few limitations like deposit and anything I mentioned earlier, that you should always have any permission to manage for your pure proxy to be manageable. But the other obvious thing is that pure proxy address is single chain. So creating the same, by same here I mean is that if you try to create let's say proxy for some of your accounts in different chains with the same proxy type, it will have different address and a different account ID even across those chains. That's because of the fact how pure proxy address is generated. Since we are creating a new account, we should let's say base its generation on something. So for that, in short, pure proxy address is generated by taking a few disambiguation things like proxy type that is being used, the time point, which is a block number, and extrinsic index. All of this is concatenated and hashed to obtain the address. So as you would imagine, it will be different in different chains due to different blocks and extrinsic indexes. So it's really hard to make it the same address across different chains. However, there are certain attempts to make single proxy control kind of self-replicas across different chains via XCM, but I would say it's on discussion phase. You shouldn't really rely on it right now. So do you have any questions regarding pure proxies? Mr. Limo.
Hello, everybody. Well, that's loud. Yeah, it's not really a question. It's just pointing out something that's good about peer proxies. So you can have like a group, you can say like a DAO or a business or something, and you can keep all the funds in a peer proxy. And then if the management of that group changes, it's really, really easy to change out the multi-sig signers. Like peer proxies are an amazing account setup.
Yeah, thank you. I guess we will review this actual setup you're talking about in the diagrams for everyone to view it and understand it in a visual way a little bit later down the presentation. So, all good. Let's move to the final concept in a proxy world. It's not really like a separate thing, but you can set up a time delay on your proxies. Both on regular and pure proxies can be set up with a delay in order to basically delay any operation. So you first need to announce it, then you need to wait until some certain period passes, and only then you can execute it. While this seems to be really like simple thing, it opens us a world doors for really interesting setups, which we'll review a little bit later. So let's quickly move through the example of flow of creating such an account. It's all start. We will review it in a context of regular proxies. Let's start again, as we did in the first at the first time, with a proxy account which wants to grant permissions to someone. So it calls proxy at proxy the same way that it did as in our initial example, but now we add a delay argument, and we specify for how long do we want all proxy transactions to be delayed. After transactions is established, there is a connection again from proxy to proxy, and now there is a timer icon to indicate that it's delayed. So, and now there's a little change in the flow, because instead of proxy, proxy should firstly call announce. This way it will indicate to the chain that it's planning to execute some operation after delay is passed. During this period, other people, let's say, who have access to proxy, whether directly or via proxy, other proxies, they can cancel the operation. There's even a separate type, permission type called cancel proxy, which only allows to cancel other proxy calls, which might be useful if you're like optimistic for what will be like suggested for execution, but you want some fallback in case of some, I don't know, malicious actions going on. After the delay period passes, you can call proxy announced and thus execute the operation. Not that operation won't be executed automatically. You need to call proxy announce for it to be executed. So what does it give us? I guess the only set of setups, it's not a single setup, it's like a category of setups. It's optimistic voting setups. It's not really for voting, but I name it like that because it's about one group of people suggesting the operation, another group that can cancel it. So we will again review the setup in a visual way in the next section. So I want to stop a little bit on proxy deposits, because I think it's important to understand how the money will be reserved on your account before actually resolving them. So the total proxy deposit in any given time is sum of two things. Firstly, there is a base deposit which is reserved only once for your account. And then there is pure proxy deposit, which is reserved for every new proxy created. So there's a little bit of math, which is pretty simple. So total deposit is like base deposit plus the amount of proxies multiplied by pure proxy deposit. And from this equation, you can deduce the total. When adding a new proxy, the difference in reserved balance will be the pure proxy deposit itself. Pretty simple, but yet important to know to understand how much funds you need to have reservable before establishing a proxy. So, and now I want to give you a little bit of information about internals of how proxy works. To demonstrate it like in a really clear way, I want you first to think how would you actually implement proxy by yourself. Does anyone have any ideas? Like if you're a substrate developer, maybe you can describe in the general steps how you would do that.
What type of proxy? Is it proxy or regular?
Like regular proxy.
You could do it with OpenJS apps.
No, I mean if you are writing the code, like from the code perspective.
You would call the proxy add proxy call with the account that is set up as proxy, the type of proxy.
Mhm. Yeah, that's how we would interact with the existing palette. But I wanted to actually like try to like think about how we would implement the palette by ourselves. Like, what would be the internal work? Yeah, but thank you for your comment. So we can actually like just think about the general steps to be the following. So we firstly, again, we somehow set up a set of permission levels and let them decide which calls they can filter accept and which ones they cannot. And then when executing proxy.proxy call, we can check if we have enough permissions to execute the call. However, there is a slight, not actually slight, but a significant problem in this approach, which is about how do we deal with recursive calls. Like, an example of recursive call is a batch call, when you can execute multiple operations inside one. So, for example, if I want to allow a proxy to execute transfer, okay, I can whitelist the transfer itself, right? I can just say, okay, we allow for a certain proxy type to execute transfers. But how do I ensure that transfer as a part of the batch will be checked the same way? I guess the simplest way you could proceed is, it's actually here. You could proceed is by matching, using like pattern matching to deconstruct your runtime call and check it against any variance it has against batches. Multisigs, it's against a proxy because proxy calls can be nested. So yeah, we could do that, but there's an issue. It's not scalable and generic. So since proxy palette is meant to be used in many parachains, it shouldn't be actually aware of what like calls are supported on a specific chain. It shouldn't hard code its knowledge about batch, multisig, or whatever. So it's not a solution we will go for usually. However, Substrate offers us a nice mechanism to achieve our goal, is to modify origin, which we will dispatch the call with, by adding a filter on it. So how does it work? When we have an origin we want to dispatch a call with, we can alter it to apply some filtering, change some stuff in it. And in this case, we can add a filter which will check any call dispatched with this origin against some certain Boolean condition, let's say. In that case, we are just basically letting the proxy permission to decide how to filter the calls dispatched with this origin. This code is a little bit simplified because I removed the part from the Boolean condition which separately handles the proxy management procedures to ensure security of the palette, to give you just a basic idea how it works. So why actually it's so flexible? Because we don't decide ourselves whether we should handle some call as a nested one or not. It is the implementation of the call that will decide that. Because when implementing a call in a palette, you can actually, like nested call, you can either choose to create a completely new origin, thus basically dropping all filters that were passed to you initially. This is the way how multisig works, for example, because multisigs meant to execute with a full access. So for example, if you do proxy and pass multisig operation inside it, like the real operation won't be limited by proxy rights. It will execute with full access to multisig account. Or you can use, I don't know, as derivative in utility as derivative, which actually takes into account whatever filters there were on the origin. That's how we can make, and actually pilot proxy makes itself really generic and scalable and configurable. So I hope it wasn't too boring for you to look at the code. Now we will actually look at some diagrams, finally. So that's use cases we will take a look on today's session. We'll start from the easiest and then move to more complicated ones. So we'll consider 3 of them. A delegation from your cold wallet to a hot wallet, then flexible multisigs, and optimistic voting. So let's start with staking delegation. Let's imagine you have some cold wallet where you store all your millions of dots. It's a Ledger or Polkadot Vault or probably other cold wallets out there. And then you have a hot wallet, which is Nova, Talisman, or other wallets which are available for you to use. And you are really unsatisfied with the amount of time it takes for you to grab your ledger to sign the transaction. So you want to make your day-to-day operations like claiming staking rewards or whatever easier for you. So you can set up a proxy from your cold wallet to cold wallet by only allowing staking operations and thus limiting the exposure of your cold wallet to the world, to your hot wallet. Yeah, that's I would say the most common setup, which can be used by really regular users which are just staking, because cold wallets are now, I would say, kind of common sense. It's not for geeks, it's for a lot of regular users use Ledger, Polkadot Vault as well. So this scheme can simplify their lives pretty decently. Now let's look at the little bit more complicated setup, which is actually what we were talking about as the first section, which is flexible multisigs. So here, the basic idea is to mitigate the limitation of multisig here, that we can change its signatories. So what we do is we use not the multisig as a main account of the setup, but we rather create a pure proxy, thus ensuring nobody except multisig can control it. And we are sure about it because of the guarantees that pure proxies is providing to us. Multisig can execute any operations on behalf of pure proxy. And suppose we are unhappy with one of the signatories because he is a bad guy. So we want to remove him from a multisig. How do we do that? Well, we actually create a new multisig only with the 2 signatures available. And we assign any proxy to it by signing from the old multisig. Of course, in order to do that, there should be a consensus reached by the alt multisig, but I guess that's the reasonable thing to have if you consider like changing signatures. It's natural to think that there should be a quorum to actually change the signatures for a multisig. So we add a new proxy and remove the old one. You can do it like in one operation. You might think it's quite cumbersome, but it's actually really easily automatable in UI. It's just by clicking. It could be done like in a click of one button and just moving signatories around 2 lists, for example. So that's actually what we are doing and planning to do in Nova Spektr. This is our desktop enterprise wallet. And finally, let's move to the real beast, which is this setup, this octopus here, which is about optimistic voting. So the main idea behind the setup is to reduce a burden for actually people who utilize the setup to sign as little transactions as possible. So idea is to have a 2 set of people. They could intersect completely or to be completely separate people. First set of people are submitters and who can submit operations, and the second one is cancelers who can cancel operations. And the beauty of any proxy with a delay here is that we can set up multiple, let's say, permissions with multiple delays depending on destructiveness of the operations. So, for example, we can have any submitter, but with a delay of 1 week. because doing any operation is destructive in a general sense. However, we might have staking any proxy with a delay of just 1 day because we are sure you can't really mess your setup with the staking operations. And of course, it's always better to have an emergency proxy to allow to execute operations instantly. Instantly, I mean when it's signed by emergency account. Here it's better for security purpose to have a multi-sig, but it can be adjusted for your use case if you feel okay giving access to your cold wallet, it's also fine. There are also a set of cancelers who can cancel the operation. So if they find the operation malicious, they can cancel it during the delay period. Of course, you can also organize a canceller setup however you want. For example, you might want to have a multi-sig for cancellers as well because you don't want a single person like ruining the whole delay just for fun. So yeah, basically this is a basic idea, and you can change right and left parts however you want and however fits your case better. And now it's demo time. Let's actually view some videos. Let's check how you can set up a flexible multisig, this big scary structure from Nova Spektr. There's a video that should load pretty soon, I hope. If not, I will show you an offline one. So yeah, we firstly start with a main screen. We go to add a new wallet. We select a multisig. Here there are a few options available: a regular multisig, which is not flexible, and a pure proxy multisig, which is flexible multisig. After reviewing information which I actually discussed a little bit before, you enter the wallet name, you select signatories, either from your contact book or by directly pasting the address. It is not the fixed set of signatures, it is the initial set. So you can, of course, change it later if you want. So then you sign it with a ledger, with a Polkadot vault. In this example, we are signing with Polkadot vault. And once done, we will have a freshly created flexible multisig. And now let's see how you can transact on behalf of this multisig. It's all about actually getting to some certain operation like sending dot, specifying a set of parameters for your transaction. At the top, you can see a signatory. So if you have multiple signatories connected to your app, you can select any of them for the signing process. I mean, you can select multiple of them if you like simulating weights in your multisig by having 3 parts where 2 of them are yours. So once the operation is signed, it will be, since it's a multisig at the first place, it will be sent for you for other signatories to sign, as you can see here. Yep, that's basically all. As you can see, it's not that hard, and that whole on-chain setup can be easily incorporated into a nice-looking UI for you to use in HLS on a day-to-day basis in your corporate, personal, or whatever use cases. And now let's move to a little bit simpler use case, which you can access right from your pocket. So it's the same use case I was talking about cold wallet and a hot wallet. So let's assume you have a cold wallet connected to your Nova. It's indicated by this little indicator, which indicates that we are connected to Polkadot vault. And you want to set up a proxy for your other account, which is like hot wallet, to quickly climb rewards or stake more or anything else. So you can do it pretty easily. You select account you want to give permissions to, you review the proxy deposit, other contextual information, and sign it with your cold wallet. This is the only transaction you will have to sign with your cold wallet. Others you can do with your proxy, and we will see how. So once the proxy session is established, you will notice a new category of wallets added to your list. It's called delegated to you wallets. So as we see, we have a cold wallet which is proxied here. So we can go to we can select this wallet and view the whole application from its behalf So it's easy for you to actually see the state of this cold wallet. It's like viewing the whole cold wallet from your application, and of course you can make actions since you just set up a proxy. So it works the regular way, the same way you would do it with a regular account. You select a recipient, enter the amount of DOT. For example, we are considering the transfer use case. You confirm, and on a confirmation click, you will see. Sorry. Yeah, somewhere here. And on confirmation click, you will see a pop-up notifying you reminding you that it's a delegated wallet, so the transaction will be initiated with the other one. There are some under the hood things like who pays the deposit, who pays the fee. You don't actually need to worry about that until you don't have funds on this account. So Nova will validate everything for you. And if it's all good, it won't even bother you with all of the things. But if you have to do some preliminary actions like topping up your proxy account, it will ask you to do so. And that's how you use proxies in your day-to-day operations. Thank you. Thank you, everyone, for attention. I'm ready to answer your questions. And let's keep in touch by my socials. You can see on the slide.
So, any questions?
Hi. I have two questions. One is, I tried to use Spektr last time, and it asked me to connect to Matrix or login, and you didn't have this there. Is it still necessary, or?
Yeah, this is the thing we are getting, like the necessary matrix connection is the thing we are getting rid of. So this is the version I showed to you is how it will look like after some time once we finish the development of this new feature.
Okay, perfect. And the second question was, can you somehow support custom proxies? So for not like standard one like transfer or?
Sure, we actually do support them. In what way? So as I said, Nova does some validations for you. For example, it checks whether you can actually sign the transaction or not. And we have a fallback in case Nova doesn't know about certain proxy type and how to handle it. It will just allow everything like on you to let it be on your discretion. So you will be the one who will be responsible for just losing the fee if you constructed operation wrong. So for example, if you're on Hydra and you have a custom proxy type, you will be able to utilize it as well.
Any more questions? Okay, over there.
Hi, Valentin. So the question I have is, so you were showing the signatories and then like a multi-sig, and then the multi-sig was behind this pure proxy. So I've sort of been I've been exposed to scenarios where some people might want to have a signature, like each signatory behind a pure proxy, and then all those pure proxies behind this multi-sig. And with that setup, and for example, I tried using Multics, and Multics, for example, didn't support that, but it supported the approach that you've shown. So I guess if you've got that scenario where it might, I got some feedback from the Multics team, and they sort of said, it might be more costly to do that approach where you've got signatories, the pure proxies, and then the multi-sig, as opposed to this way. Is that? Have you got an opinion on that other approach, or is that in terms of adopting that that way of doing things in the?
Yeah, sure. To confirm that I got you right, you're talking about having proxies for signatories themselves and not for the multisig.
Yeah, so you'd have a multi-sig, and you'd have
You have proxies for each signatory here.
Yeah. So each one would be behind a pure proxy. So for example, if we want to sign something,
I would say those different setups they have different behavioral patterns when you actually need to change signatory. Of course, and yeah, Multisim was right that it is costly to set up a proxy for each signatory because you will need to pay reserve deposit for each. Just like number of signatories multiplied by deposit to make this happen. But I would say the other consideration here is that in this approach, consensus of signatories can force the change of the signatory. Whereas if you have a proxy for each individual signatory, only the signature itself can change itself, which might be inconvenient a little bit if you're ending your relations with signatory not in a pleasant way, I would say. However, there are ways to mitigate it. For example, you might combine them. So you will have a signatories proxies for each signatory, and you will have proxy for a multisig. Like combine both worlds to make it a huge setup. I would say so. Yeah, basically, I would say this setup I've shown is the most used, but I also saw a feedback, heard a feedback that the setup with proxies here is also used by some teams. So I guess it's also worth considering it in enterprise wallets as well.
Yeah, there was a question.
Hey, this is Tiny from Email, which is another multi-sig tool in Polkadot ecosystem. And actually, you at this page you mentioned flexible multi-sig. Yeah, we have this function as well, but we met some problem that once you want to create a flexible multi-sigs, you have to deposit at least 40 dots. It would be a huge amount if in the future maybe bull market. So I think maybe we could start some proposals to in OpenGov to make the deposit is flexible. And how do you think about it?
Yeah, so I guess the deposit is actually around 20 dot, not 40. And yeah, it's controlled by governance. So if the community decides that the decision deposit is big enough once the price changes for a significant amount, this actually happened on Kusama. So there was a time when Kusama was on one price and it like went up by a considerable amount, and fees, both fees and deposits became a little bit inconvenient for users. So the Kusama governance lowered them like 100 times, I guess. I would say dot governance is a little bit more conservative here, but usually if overall consensus is about lowering them, it will happen.
Okay, another question.
GM. This is going back to Luke's question previously about adding pure proxies as signatories. So I don't know the answer to this one. So for example, with time-delayed proxies, they just straight up don't work in Polkadot.js apps, right? Whereas in Nova Spektr, they're going to work. So that means that Polkadot.js apps isn't like the be-all, end-all of proxies, right? So in Luke's example, where you have the peer proxy controlled by a multi-sig that's in any proxy, and that multi-sig consists of some signatories that are pure proxies themselves, you face an issue where one of the pure proxy signatories cannot instruct the other pure proxy to do stuff on Polkadot.js because you get the cannot sign with locked key pair problem. Is that a JS problem or is that a general Polkadot problem?
I think it's a JS problem. There's a couple of issues related to complex setup and nested structures in Polkadot.js. For example, the simplest one is just you just can't use multisig with pure proxy at all there, as far as I remember, for my knowledge. So yeah, it's the issues of Polkadot.js, but in terms of on-chain, it is possible.